right, so let's talk about individual elements and how their information that you can find on the periodic table, what it tells you about the charge and the protons and neutrons and electrons. So the first thing we want to look at is called the atomic number. And when you're looking at the periodic table, okay, the whole number that you see with an element is called the atomic number. And the atomic number represents the number of protons in the nucleus, and it identifies the element. So the number of protons is what makes that element that element. So any atom that only has one proton in the nucleus is a hydrogen atom. That's what defines it as hydrogen. All right, so let's take a look at some examples. You're going to need your periodic table, so if you don't have it out, pause, go get your periodic table and bring it back. So if we look at the element lead, Pb, find it on your periodic table, it's number 82. If its atomic number is 82, then what do we know about the number of protons? Well, we know that the number of protons is also 82. Okay, so the atomic number is the number of protons. That's what makes that atom lead. Now, if we think about electrons, we know that protons are positive and electrons are negative. So for an atom to be neutral, the protons and electrons have to be the same. So lead atoms also have 82 electrons. Okay. All right, now let's find an atom with 8 protons. Well, that means the atomic number is also 8. And which element has an atomic number of 8? Well, that would be oxygen. And we know that if there are 8 protons, there are also 8 electrons. Okay. Now for the third one, we have 30 electrons. That means we have 30 protons. The atomic number is 30. And what element has an atomic number of 30? If you take a look at your periodic table, that will be zinc. Okay, go back. All right, so we know about the atomic number, we know about protons. Now we want to talk about neutrons. So all atoms of a particular element have the same number of protons. We just talked about that. That's what makes it that element. They also have the same number of electrons, but the number of neutrons in the nucleus can differ. Atoms with the same number of protons but different numbers of neutrons are called isotopes. And in nature, most elements are found as mixtures of isotopes. So there are rarely any just pure elements that are only one isotope. For example, in a banana, 93.26% of the potassium is potassium 39, and 6.73% is potassium 41, 0.01% is potassium 40. Okay. So when you're looking at the isotopes, you represent the isotope with the name of the element and then this number at the end. Okay, so that number is called the mass number. And the mass number is the sum of the protons and the neutrons in the nucleus. So in our example, potassium 39, the 39 is the mass number. We know from the periodic table that there are 19 protons in potassium because that's what makes it potassium. So in this isotope, there has to be 20 neutrons. 19 plus 20 is 39. In potassium 40, there are 21 neutrons, and in potassium 41, there are 22 neutrons. So, knowing the element tells us the protons, and then the mass number at the end can help us figure out how many neutrons there are, because we can't get the neutrons from the periodic table. The periodic table tells us something different. Now, the other thing you can look at is when you're using the symbol instead of the name. The protons go on the bottom, so that's the atomic number, and then the mass number goes on the top. All right, so here we go. We want to solve our problem. It says, a chemistry laboratory has analyzed the composition of isotopes of several elements. The composition data is given in the table below. Determine the number of protons, electrons, and neutrons in the isotope of neon. name the isotope, and give its symbol. Okay, so find neon on your periodic table. It tells us here that the atomic number is 10 and the mass number is 22. Okay, so let's look at what that means exactly. So we have neon, and it told us the mass number was 22, so we would call it neon 22. That's the name of the isotope. Now, we know that there are 10 protons because that's what neon is. It has 10 protons. So that means we also know that there are 10 electrons. Okay, so we want to figure out the number of neutrons. Well, the mass number is 22. 10 plus what is 22? 12. So that means there are 12 neutrons in neon 22. And to write the symbol, we would use the symbol for neon, the mass number on top, and the atomic number on the bottom. Okay, so neon 22, neon 22. Two different ways of writing the same thing. Okay, so we've talked about mass number, but we haven't actually talked about the mass of actual atoms. And we use a unit called an atomic mass unit, or an AMU, to define the mass of an atom, rather than using those tiny itty-bitty little numbers in grams that we saw earlier. Scientists redefined the mass of an atom to equal 1/12 the mass of a carbon-12 atom. So 1 AMU is not exactly, but nearly equal to 1 proton or 1 neutron. Okay, so it's not exactly equal, but it's very, very close. And you can see using AMU what the mass of each of the subatomic particles are. So that's why we can call the number of protons and neutrons the mass number, because it's very, very close to the actual mass of an atom. Now, when you look at the periodic table, okay, the atomic mass that's given isn't a whole number. It's a weighted average mass of all the isotopes. So, for example, when you look at chlorine on the periodic table, your mass is 35.453 AMU. Okay, so what that tells us is that because it's not close to 35 and it's not close to 36, that tells us that there's more than one isotope. Okay, so that number on the periodic table is a weighted average of all the isotopes found in nature. So what you can see here is one isotope is chlorine 35, the other isotope is chlorine 37. Okay, so this says that chlorine 35 is 75.78% abundant. So that means if you found 100 chlorine atoms in nature, about 75 of them would be chlorine 35. The other 25 would be chlorine 37. So to find the weighted average, you're going to look right here. You're going to take the mass of the isotope. You're going to multiply by the percent, and remember you have to take your percent and turn it back into a decimal, and that's going to give you the mass contribution from each isotope. And then to find the average atomic mass, we add up all the contributions, and then this number should be what's on the periodic table. That's the weighted average that we see on the periodic table. So let's see if we can do an example here. All right, it says, given the data in the table, calculate the atomic mass of unknown element X. Then identify the unknown element, which is used medically to treat some mental disorders. All right, so here is our data. So we have some element X, and it tells us the mass of each isotope and the percent abundance. So you're going to need your calculators out. If you don't have your calculator out, you need to pause and go get it. Okay, so for each isotope, we're going to start with element X isotope with a mass number of 6. We're going to multiply the mass, so 6.015 times the percent abundance, and remember we want to put it into a decimal, so 0.0759. And when we multiply those two numbers together, we get 0.4565 AMU. Okay, then we do the same thing for the other isotope. So 7.016. We're going to multiply that by the percent abundance, so 0.9241. That gives us a mass contribution of 6.483. And then we want to add the contributions together to get the overall atomic mass. So 0.4565 plus 6.483 gives us a mass of 6.9395 AMU. And that number makes sense. If the isotope with the mass of 7 is 92% abundant, then the average should be a lot closer to 7 than 6, right? Because the 7 is contributing most of the mass, 92% of the mass. So our number makes sense that it's close to 7. And if you look at the periodic table and you find an element whose average atomic mass is 6.935, we can determine that element X is lithium, which is used to treat some mental disorders. So we came up with our element and we used our average atomic mass to determine what that element is. Alright, make sure you bring these calculations to class. We are going to be doing a lot more practice with them, so have your calculator, have your notes, and make sure you bring them to class on Monday.